Data mining is a recent technology to discover interesting patterns in large amounts of data. So the key point here is interesting patterns, and how do you define what is the meaning of an interesting pattern? This is a very ambiguous statement. What is an interesting pattern? So actually different researchers have come up with different meanings of what is interesting, and people have formulated strict definitions of what constitutes interesting patterns, and we'll go through them as each chapter we see in this book. The main motivation for data mining is that nowadays there's a large amount of digital information which is being made available in the form of data. So for example, you have a large amount of financial information in the form of stocks. Every day when different stocks prices, they increase and decrease and so on, there's a large amount of data being available. And you have data in the form of sales of all the businesses that are happening in the world every day. So in almost every store, this data is being stored digitally. So whenever you check out from a supermarket, for example, there's somebody at the end of the store who's storing all this data. And so in addition, there's also a lot of scientific data being made available. So if you look in the science labs, let's say bioinformatics labs, genetics, in all these subjects, there's a large amount of data being made available. In addition, the World Wide Web is also a large collection of data. And other collections of data include digital photographs, and videos, and all these kinds of multimedia data, audio, all these kinds of data are being generated every day in large amounts. And the amount of data that is available is actually too large for anybody to make sense out of it. So a single human user cannot make sense of all the amount of data. The number of books that are available in the world today, if you read even one book every day, you cannot finish all of them. So how do you make sense of all this data that is available? So you need automatic means, automatic methods of how to analyze this data and to get you the data that you need, that you will be interested in. So this is the purpose of data mining. Okay. So as a motivational scenario, imagine that you are the owner of a large supermarket, okay, and a large supermarket chain, and you have large number of transactions happening every day. So lots of customers are buying lots of things from your shops every day, and you're keeping track of all this information digitally. So at the end of every day, you have terabytes of data, or maybe gigabytes of data, and you have so much of data. What do you use this data for? Okay, so far, before data mining came into picture, you could only use this data for, let's say, accounts and inventory purposes. And what else would you do with this data? This data would fill your hard disks every day. Once the hard disks get full, you will take this data and store it on other devices, let's say DVDs or tapes. And as those get full, you will store all of them on, let's say, some shelves. And when the shelf gets full, you will actually take it and throw it into the dustbin, right? And there it will rest in peace. And so that's actually a big waste of all the data that you're using. The natural question that arises is, can you use this data for some better purpose? And it turns out, now that data mining has come, it turns out that there is a very good use, and you can actually, there is gold in this data waiting to be mined, and that's the reason why we give the name to the subject as data mining. And this gold is in the form of interesting patterns that you can mine from this data. And once you mine these interesting patterns, you can use these patterns to change the way you operate your business. Let's say, for example, that you get from the data that you have mined, you get some patterns of this kind, that 90% of the people who buy, let's say, screwdrivers also buy hammers. And they buy these hammers not immediately on the same visit, but maybe in the next 3 visits that they come to your shop, they buy a hammer. So by looking at these trends, you can actually put the hammer next to the screwdrivers. Wherever you place screwdrivers, you can also put hammers, or you can give hammers for free if they buy screwdrivers, or for a discounted price, and that will actually improve your sales. And so this is one of the scenarios in which you can use data mining. Another scenario is when, let's say, you are the director of some university abroad, a large university in the world, and you're getting lots of applications from students for admissions. Now, you can use data mining by looking at which kind of students in the past have been successful by looking at the data that you already have of your existing students, that maybe people who initially, before you're given them admission, people who got 80% in mathematics, they did very well in, let's say, C programming and so on after they got admitted. So by looking at such kinds of data, you can actually decide who to give admissions to and who not to give admissions to. So these are some scenarios. There's no limit on the kinds of scenarios you can come up with. Wherever there's large amount of data, you can apply data mining. And we'll see a lot more example applications in the chapter. So the subject of pattern discovery was initially in the domain of artificial intelligence, AI. And because AI did not achieve all its grandiose objectives, it has broken up into several smaller subjects like pattern recognition and machine learning, data mining, and others. Now there's a lot of overlap between these subjects, let's say pattern recognition, machine learning, data mining. The key thing that distinguishes data mining from the other subjects is that in data mining we are more interested in making the end user aware of the patterns that are being mined. Whereas in machine learning and other subjects, we are more interested in using these patterns for the machine to do intelligent tasks. Here the end user has to know these interesting patterns, and the end user uses it for other purposes. So, and the second key difference between data mining and the other subjects is that here we deal with large amounts of data. And the data could be in, let's say, gigabytes to terabytes. So, whereas the other subjects look at more smaller data sets which can fit into main memory, and in the main memory they can do complicated processing on top of it. So, that makes data mining both challenging and very interesting. So data mining has become a very successful subject in both academics and in the industry. It has been very successfully used for lots of different applications. In the industry, future trends include using it for lots of different newer applications. And there's no limit to what applications are possible. All that you need is a large amount of data. So your mind is the limit in what you can use it for. Whereas in academics, you can use future trends in academics include several different topics. I've just listed 4 of them here. The first one is about unified theory of data mining, which is there are several different techniques available. People have come up with all kinds of techniques for data mining. Can you unify all these techniques into one unified framework? And that's a very challenging problem. It's not solvable in the near future, and it's a very interesting problem to work in. The second thing is about mining data streams. There are lots of applications where data comes in the form of a stream, a high-speed data stream, things like stock market applications or computer networks, telephone networks, all these kinds of applications, they generate large amounts of data continuously. And you cannot store all this data in one hard disk because the data is coming too fast, too soon. So how do you mine such data effectively? So that is one very interesting topic. The next topic is about parameterless mining, in which the key idea is most of the data mining techniques, they require the user to enter different kinds of parameters. And what is the meaning of these parameters is not clear to the end user. So it's like a black art of how he can set what the values of these parameters should be. And can you actually, instead of asking the user to set these parameters, can you set them automatically yourself? Or can you develop techniques which don't require parameters at all? So this is another interesting trend or interesting topic to work in for people who are looking for research in data mining. And the last one is about proactive data mining, where the user doesn't even have to initiate the process of data mining by starting a software or so on. Instead, as data comes in, so you change your database management system itself so that as data comes into your system, the system comes back to you saying that, see, here's one new pattern has emerged as the data is coming into the system. So here the user doesn't need to initiate the data mining task itself. So these are some of the trends, or these are some of the areas of potential research